Okay. Well, I feel somewhat like I'm preaching to the choir here. All the experts are sitting in the audience. But as I mentioned before, after the last several fox hunts where Brian and I were swapping first place, I thought I would share all the mistakes I've made over the last, I guess I've been doing it for almost 20 years, and share some experiences and how we tried to improve things. I'll start with a little story though. The first hunt I was on, I remember Bob was inviting me, and that was great. Started a great part of the hobby, and I was trying to figure out what kind of antenna to build. I built this little Moxon antenna and practiced with that a little bit. I remember meeting up in Wegmans, and Fred was hosting it, and I had the mindset that I didn't expect to win. This is the first hunt. And not having that mindset is probably a good mindset. Remember, we spent a half hour in the parking lot before we took off, got a good first reading, plotted on a map, followed the line out, took a couple perpendicular readings, finally got a right angle reading right into a park, and basically almost walked right up to it. But it was the being methodical and not being worried about first place, and then waiting 2 hours for lunch. But since then, I fell into a lot of bad habits. I would come in either second or dead last. And so what I'm trying to do here is to encourage other people. You don't need a lot of tools, and you can do pretty well, but the key thing is focus on strategy. So next slide. So I'm going to give a little brief summary of how our hunts work, and then emphasis. As I said, focus on strategy. Don't need a lot of equipment. There are some better tools that will help, and some advanced tools that may help. And then we've got a hunt coming up in October. Next slide. So what do we do? We generally meet some location, some parking lot, and around 9 o'clock, we have teams of 2 or 3 people in each team. It's always good to have at least 2, because you don't want to be driving and mapping at the same time. That's a recipe for not good things. So, and 3, brought my partners along with me. You got Gregory and Vince, and Karen wanted to come and listen to the talk. Maybe she'll join us on the hunt next time. Idea is find as many as possible. We've evolved from just having 1 fox to now typically hiding 3 or 4. And the idea with the 3 or 4 is we make a couple of them that are relatively easy to find, so that everybody gets up to midway some way, and make one that's kind of a challenge. So what do we have? We got these hidden transmitters. I'll show a picture if we've got one over here. And we made these after we had several failures. Remember, we had one hunt Vince and I were on hunting, and we were hearing 2 or 3 foxes in the same frequency. Less than ideal. So Vince and I actually worked together and put these little transmitters together, and we've dubbed them fox bitters. So I'll be referring to looking for fox bitters throughout the hunt. And that's got some nice characteristics in that you can set multiple frequencies in the field easily. And you can broadcast, tell people what those frequencies are ahead of time. And this is the message typically. And you'll see that about once a minute, or hear that about once a minute. And after a while, you'll learn the Morse code too. Will come very clear. So I guess I've covered pretty much that. Oh, the other thing is we've gone to having these tags. We got a picture of the next one, I think. Next slide. Yeah. So I've gone to these tags, and this must be an old picture because 0's on top. It used to be we hunted for the low numbers, took the low number tag, and the person with the lowest score would win. Of course, somebody found nothing, got the lowest score. That didn't make a lot of sense. So we've gone to having the high numbers win. So like now we have tags on, like on this one, where number 9 is the high number. So you pick up the high numbers. I can remember the first time we did this, I was rushing away. I didn't listen to the instructions too well, and I picked up all the low numbers, and I thought I was pretty good until I realized at the lunch that high number won. So I said, well, I learned that one the hard way. Next slide. So I thought I'd do a walkthrough. This is one of our hunts. I think it was the first hunt we used these transmitters on, or maybe the second. Second, okay. And this hunt, I said you can hear 3 out of the 4 transmitters right from the beginning. The beginning was right up here in the parking lot. And they didn't have this diagram, obviously. But as you listen to it, you say, oh, well, wait a minute, maybe I'll go after the strongest one first. Well, it turns out the strongest one was this link here. And what I had done is I took our 7-watt, we had 7-watt transmitters here and here. And we took the 7-watt transmitter and the antenna, had a fairly long lead in on it. And I just bent over a tree, hooked it up and let the tree bounce back up. So we're on a hill, top of a hill, and the tree. So we ended up with a very strong signal here, reasonably strong signal here, and the weakest signal from here. Well, I think everybody, I don't remember John was on this hunt, he can chime in. I think everybody ignored the weak one here and went either for this one or this one next. Going down, straight down here, just following the lost artist signal would bring you into Mendon Ponds, and that's loaded with valleys and difficult places and lots of reflections. I believe Brian commented he got kind of lost with reflections on this hunt. But eventually this was easy to find if you would triangulate. So what the point I'm getting at here, getting a strategy where you stop often and you get accurate readings and try to triangulate. Because if that had been done, you'd very quickly realize that this was north of where you were rather than south very quickly. If you'd stopped about here and taken a reading, then you'd gone up and you take a perpendicular reading, you would have found very quickly that it was just off the parking lot by about maybe 50 feet behind a tree. And that would have been an easy pickup. But instead, I don't think anybody did that one first. Everybody started down for one or the other. You get down to here, but then getting in here and doing the parking lot or just following the strong signal into the park, you get flooded with reflections in here. And you ought to get in the habit, and I always fight this impulse, but not do that, but rather drive down a parallel road, pick up a perpendicular signal, triangulate, get a couple of those, and walk in that way. If you off at a distance, then the main signal is going to be stronger than reflected signals, and you get a good reading. And you start, if you actually keep track of it on a map, you would have mapped that out pretty close. Come in down here, up there, and avoid all the hassle in here. And then, of course, that would have been a straight shot across here. But a similar experience over here. If you just get into the park and start going around again, this was at the top of on the hill above the mill and the stream. And I know at least one person actually scrambled up that 45-degree bank to find it, but didn't have to do that. If you'd actually triangulated, come in across here, got a couple other readings, it would have been obvious where it was. And then you go in and find an easy way up. So the whole thing is plot out your strategy, triangulate, be accurate, use a compass, and I think you'll find that you do a lot less. I remember one time, I think it was Bob hit a transmitter up along the lake, but the reflections across this chain link fence that ran at the end of this road here was strong. And I spent, what was it, 10 minutes, 20 minutes along the fence. Finally, you can't be here.
It's a barrier, it's the kind of stop people from running off the road.
No, this was on along the chain link fence. Oh, no, that's another one. Yes, that's another problem. But the idea is, if you triangulated ahead of time and gone out for an orthogonal reading, I would have never wasted time at just wandering around the reflections. Reflections, you think you got it so many times and you don't. So that's my message. Next slide. So again, be methodical, get a good compass and a good map and use it. Temptation is ignore mapping. I just follow the signal. That can get you into more trouble than you care to think about. And that is getting accurate bearings would be the key thing then. We're going to spend some time on that. And also how to triangulate And again, avoid following just the strongest signal. Go ahead. So you got to start with a radio. Now, I think just having a good handheld radio is essential. May not be the only radio you use, but it's certainly essential. This is a picture of the one I used, it's the Yaesu, and it has a cast aluminum package on it. And that does a great job of insulating the receiver inside the radio from signals coming in, stray signals. In fact, I was testing it today, and if you put a dummy load on this, I can set this next to the 7-watt Fox, and it only goes half scale in this meter. So getting a handheld that isn't going to let a lot of leakage in, your struggles around the Fox itself won't be quite so much. So that's a minimal thing. As I say, it's aluminum casting, but check out what you have. I was surprised the difference it made by terminating that antenna with a dummy load as opposed to just leaving it open. Leaving it open, I was saturating it with the S meter. I put a dummy load on it, matched it, and I got 50% signal. So I could walk around the basement and still find my radio, the transmitter. So that's something I wanted to pass out to people because I think a lot of people struggle with close-in work. Also, if you're buying one, you're happy to say it's time to buy a new handheld. So look for one that's got a little aluminum case, good dynamic range. There's a lot of comments if you go to homingin.org or whatever it is. They'll talk about all the Japanese radios where the dynamic range is not good at all. It saturates. Another thing, I made a mistake once. Vince here was hearing the signal great from the parking lot, and I could not hear it. What is wrong? Why can't I hear it? Well, it turned out that somewhere along the line, I had switched to wideband FM. So I was letting a lot of noise in for my signal noise ratio went to pot. So check to make sure that you're doing a narrowband FM, and that'll give you a better signal noise ratio. Another thing is I will always send out on the email ahead of time what the frequencies of the Fox emitters are. Pre-program your radio, whether the one in the car or the one in your hand, so that you can actually scan them. Because I'm going to say, here's the 4 frequencies. They're all on right at the same time. You can choose which one you go for first. I do that so that everybody goes in the same direction. You just follow somebody. I'm going to follow Brian. He always gets it. So, but it's easier to do that if you have it pre-programmed. Last time, I ended up spending a half hour in the parking lot because my radio broke, and I had to reset it software-wise, and finally got working. But it's check out your equipment ahead of time, yes, too. Then the other thing is when you're doing body fading, don't just say, "Oh, it's behind me. Let me turn around." Take the compass, let the direction of travel face you with your arms rigid, and then take a compass reading, and you'll be actually reading what's behind the direction behind you. Then turn around, just follow your compass, as opposed to just looking back. Oh yeah, there's a tree there. I'll follow that. You can be much more accurate. Greg and I were out checking out places to hide the Fox a couple of weeks ago, and we forgot where we hid it. It was a confusing set of trails. So I actually had to use body fade, and we found it in, what, 2 hours, right, Greg? No, I'll find it in a few minutes. So, okay, next slide. So what's important to compass? I think it's worth making sure you have a good compass. This is the one I have over here. And a little story about this. I decided to use their advertisement because the Bronson compass, I've been using it for several years. And this year, when I went checking things out, I noticed that the compass is very sluggish and very slowly pointed due south. So it actually lost its magnetism. So I called up the company, or wrote them a note, and 2 days later, I had a new compass inserted in the mail. So that's a US-made company. That's what I made in USA. So that's a little advertisement there. But a good compass, there's a couple made in Sweden that are very good. Recommend those highly. This one works out very well once it's magnetized. but the company backs up their product. It's been like 6 years since I bought it. I like the large base plate because it's very easy to move from your compass reading to where it is on the map. Get a good map. I think Google Maps works fine. Print them out ahead of time. You can print out one that's maybe 6 miles around where the start point is. Then you might want to print out the quadrants too, get like 4 or 5 maps, and you got something to write on and something to draw your pictures on and your bearings. So I really believe the times we've come close to doing that. We don't do that all the time. We get this, oh, there's a strong signal. Oh, it's off in the left direction, and we kind of go that way. Where's the big parks? And those we've lost a lot of time that way. So I've convinced myself, especially after doing all this research for this talk, that getting maps and using them, and getting the compass and using it is good. Must. Go ahead. And there's a picture of a map that's showing up very well. But if you download the presentation, you'll see it better. That's an example of Google Map bigger. Go ahead. Another type of compass that's popular is the military trinium lensatic, I'm pronouncing it wrong, compass. Theoretically, you can get better readings that way, and I believe that's true. One of the nice things about it, because they get their damping because the disc is what moves, and that's got some momentum to it. And the benefit of that is not filled with bubbles, not filled with the fluid. So you're not going to create a bubble over time. So these are the ones that the military uses, I'm told. And it's got scales both in radians and in angles, degrees and angles. So getting used to both of those is pretty good. So you can get more accurate by reading the outside, which is the milliradian, 20 milliradians per small division. It's there. Maybe you don't need that accuracy, but I wanted to, just so you know. Go ahead. But whatever compass you use, do not ignore magnetic declination. That's the variance between what the compass reads and what true reading is true north. And here's a map showing you that. Now we happen to be along the 10-degree line, approximately here. Around Chicago, it gets to near 0, and then it gets higher as you go west again. These are called the easterly corrections. And to go from compass reading to true, you subtract it. And then the westerly ones, I'm sorry, these are the westerly ones. They tilt west. These are the easterly ones. You add those corrections when you take a reading. So we're going to really be in the 10-degree range. And that's a little, just memorize that. Some of the compasses, you can preset those. I find that actually can introduce confusion. I just memorize which way you go, and it works out. Really, we'll only be going from the compass to the true. So it's always subtract. And I put that down there. Why is it important? Well, if you got a 10-degree error at a kilometer, that's 174 meters, or like 2.5 football fields off. And that, so it's quite a big difference if you're not, don't pay attention to that. Next slide. So what is the declination that we want to use? Here's a link that you can follow. It takes you to Noah's calculator. You put in your zip code, it automatically gets the latitude, longitude, and then when you say calculate, you get this answer. And we're 11.3 degrees where the foxes will be hidden this fall. So I did that for you. Next slide. And then this just goes through what I said. What we'll be doing, getting a magnet reading, subtracting declination, and doing a true map on that. And actually the flat face-based flat compass like this, faceplate, makes it easier to go from the reading, subtract it, and do the map, and then you don't need to have a separate compass, a triangle compass. So lay it down there and you get your line up with north. You can read online exactly how to do that, practice it ahead of time. Go ahead. So, getting a good bearing. I think I talked about this. You can use body fading, and when you do it, you hold the compass so that its direction of travel is pointing toward you. You get the reading behind you, and that's just as accurate as turning it around. It's more accurate if you're just trying to guess what's behind you when you do the readings. You can't use a Yagi, most of us do. And the Yagi actually makes things more difficult when you get close because you're amplifying the signal. The Moxon, the null for directional, it actually attenuates the signal some 40 dB. So that's another option. One person can have a Yagi, another person uses a Moxon, and the two of you work together on a team. The cell phone has a digital compass, and that's fairly accurate or not. If it's not accurate, it usually doesn't work hardly at all. But you gotta go through the figure-8 circle compass above your head and get the thing calibrated if you're going to use that. And that may be more convenient for other reasons we'll get to later. I did that figure-8 like this once. Comes up on yourself. So it has to be faceplate up when you do the figure-8 calibration. Next slide. Okay, tape measure. You've got one, right? That seems to be real popular. And interestingly enough, this month's QST has a link. I've ever linked to the same place they point. Step-by-step instructions along with map or list of materials you need to make a compass. And that's the one they came up with. This was done for a ham radio club group, teaching a lot of high schoolers how to make it. So here we are, faceplate, or show them how you mount your compass. That's what I really wanted to show.
Oh,
Oh, just
I don't have it, but anyway,
just pretend.
it's right over here.
Yeah.
Velcro.
So what's the part you have here? Did you make that part?
Yes, I made that part. This is the standard design.
Yeah, probably much like this one here. Yeah.
The key difference, I didn't use hose clamps to hold the horizontal elements,
Okay.
and I added these little Velcro stick-ons to solve a problem of reducing space when you're not using it.
Oh, there you go.
So we just have it in a car just to haul around. It's folded back on itself. And then the other thing I did is the way I
The balance.
wound the balance, on the antenna here is I actually just drilled holes in the right location to be able to feed the cable through and wrap it around and hold it with only one tie wrap. I also put some support for this little loop, because I figured this going in and out of the car is easily damaged, and I didn't want to affect it either. So I put on this little piece of plexiglass that holds this loop, and it keeps it rigid in that location. The way the tape measure is held into the PVC tees here is just foam. So I could actually pull these out, I could move them around, whatever. And I did it because I didn't want to have all that metal of the hose clamps in case it might affect anything. It looks neater, keeping it plain and simple.
This does a great job. Again, tell me about the mount that you made here. How did you do that?
Well, that's very simple. I mean, I just put a 45-degree
Yeah.
handle on here. In fact, I've actually have another piece that I could take this off and mount this on a tripod and use it
Okay.
as an antenna.
But you had to make this extra additional
Yeah.
piece that
Yeah,
you glued on there.
Yeah, that's just a piece of plexiglass. It's
Yep.
glued down there. And I put that little platform on the top, and it was wide enough, so I had so the Velcro extends over the edge.
That's very nice. So, how much you spend on that? $10?
Well, I had the tape.
Yeah.
It was old.
You had the coins?
Probably the most expensive thing was the cable.
Yeah.
I bought the cable from ADR, I think. And I just cut off one connector and one end.
Yep.
And I kept the other connector.
Yep.
I actually have two.
You have two ends?
Two cables.
Two cables. Oh, that's what you cut it.
Yeah.
Yeah. Was it Amphenol on demand or something like that? Cables on demand.
Yes, right, yes.
Cables on demand. That you can order any cable you want, any terminator. Is that where you get yours, Brian?
No, the different one, but.
Same type of thing.
Similar thing.
Come in 2 days, amazing. So that's a great, next slide. Good. What's happening? There we go. And then another popular antenna for those of us who want something more rigid. I guess the advantage would be to blow around in the wind, but we use both. And you could, this is more pricey, and it's pre-built, it works pretty well too. It's the one I happen to use. Whatever, $60, something like that. 50. Gone up?
The new man.
The old one, $50.
Yeah.
About 67.
So this is nice. The only advantage of this over the tape measure one is that it doesn't pop around in the wind, but that's not the big deal.
But the disadvantage of it, and that is that it gets very heavy. You have to hang on to it. The ergonomics of that handle back there is awful.
Yeah,
And after a long box, your wrist you feel like you're bouncing.
so it sounds like we want to take notes and.
That's why I made mine with an angle.
Yeah.
$84 for that.
Oh my goodness. Oh my goodness.
And that's the.
Price has gone up.
The non-split boom, on a split boom, 90 points.
What's a split boom?
So you can disassemble it and put it in a case.
They charge more for taking it apart?
Yeah, well, it's a 2-piece, right?
Got it.
2-piece boom.
Got it. Next slide. Any event, so that's,
Yeah.
but you could, a Yagi is great at a distance. So if you're out several miles, it's good to have a Yagi in order to get a good bearing. And better than the Moxon, which is very broad, we're getting in closer. The Moxon actually gives you a very more accurate bearing possibility. Go ahead. And here's instructions up here on how to build the Moxon antenna. I built a more clumsy looking one initially, but I used the same calculator that W4RNL, it's LB Seebeck. He used to publish, he passed away, but he would publish antenna articles every month in QST. And after coming in second for my first hunt, I sent him a note and I said, gee, Moxon success. You know, my son and I went on a fox hunt for the first time and we came in second using this antenna. Not this particular design, physical design, but the electrical design. He wrote me back the next day. He says, great to hear. You made my day. He said, but don't forget, the important thing isn't the antenna. It's how you use it, how you take your compass readings, and how you map it. So that was advice from the expert. But and this just gives you what why you get that sharp null. They're very broad forward, which is equivalent to all 6 dB there, 2-element beam, which is okay. But the big thing is when you have the reverse, look at the back end going for a null, you got a very sharp null there. So they're pretty accurate reading. So that's a possibility. Play around with them, build both of them, actually try them out. Maybe next slide. No matter what you do, you need shielding. You need to have attenuation. I've already talked about this. You know, if you plan on buying a new radio, make sure that you get one that actually will give you some isolation for stray pickup. So shielded receiver is good. The coax between the antenna and the receiver, keep that as short as possible. Attenuators, well, a lot of us just loosen our handheld as we get closer. But as I mentioned before, putting the dummy load on it was amazing how much more attenuation you got by terminating that antenna terminal. I've played around with passive attenuators. Unless they're really built well, you'll let in more noise than you care for. You don't want that. Active attenuators, I didn't have too much luck with that. The Moxon works good combination, but it's hard to beat just doing your handheld and body fading well.
What do you mean by passive attenuator?
Passive attenuator, you're just switching resistors. And you can, there's all kinds of formulas for building that. If you put it on a surface mount board, and you had solid state
Here's
switches.
an example of one I built.
Does it work?
Yeah, it worked.
Yep.
The only trouble is it doesn't have enough loss on it.
What's your maximum dBs?
I think it's 33, the maximum on that.
Yeah.
Flipping all the switches.
So, I mean, I had one that was not isolated and it didn't, it was very poor. But building it right, it's great. The best is going to be if you can get one that's integrated with the receiver. And that all happens automatically. That's the best, but that's expensive. Next slide. And that's what you get here. And a few of us have, I bought mine used from a fellow that retired from Fox Hunting, and that was a good buy. They're pretty expensive buying them now, probably more now. I don't know what they cost.
I understand they got a dealer in the West Coast, used to have to buy them.
Yeah, but any event, the nice thing about this is that is the receiver. The attenuation happens automatically as you get a stronger signal. The tone goes up, so your ear is very sensitive to the change in tone. It becomes very directional. It automatically steps down as you get closer. You can take a Yagi, hook it up to here, and walk right up to even the 7-watt transmitter. Usually, right, Vince? They work great until they don't. Both of us have had the thing not work in the end. And I found that it really likes fresh batteries every time, but even that might not do it. So we're not sure what the idiosyncrasies are, but the concept is great.
$315.
Oh my goodness. No, I didn't pay anywhere near that. So,
I think I paid 180 for mine, and I ordered directly from the guy.
and I paid half price for that, so I think, but anyway. So somewhere between those, but the important is you gotta have some way to handle the signal strength as you approach the transmitter. Next.
Hold on a second. Let me show a picture of Vince's.
Yes, excellent.
Can you guys see the sniffer I'm holding up?
That's the attenuator.
Yep.
Sorry.
So something like that combined with the 40 dB null naloxone would let you walk up. So I got some more club projects here. What?
How much is that?
He built it. It's a bunch of switches and resistors. He built it.
Oh,
Well, I bought a kit of parts, and the only thing I really added to it was the graphics.
Oh. Okay. But get something that's has enough isolation that you're not just an antenna. You want it to be an attenuator.
I have one that was, it was a kit, it was, I heard it in QSD probably 20 some years ago. And it's made out of a solid block of aluminum.
Yeah.
It's called the sheet. It's got the little switches in there, you gotta, it's hard to put together. They're like precision resistors, like 1%. But I think it was up to 100.
Yeah.
140 dB.
Yeah, there you go. Well, in here, there's got to be, there's a surface, it's all surface mount, and it's very tight and good shielding on the ground plane and everything. So I don't get any straight pickup when you use this. So these kind of things as a model, great. Okay, next slide.
Looking on it.
Now, it seems clumsy. I got to carry around a compass, a radio, a drafting board, straight edges. You know, it starts to get pretty klutzy. There's a program out there called SIGTREX, and it's available for both Android and iOS. And it integrates Google Maps with very good detail, internal GPS because it's built into the phone, and if you make sure it's accurate, compass is built into the phone. And it will facilitate mapping the bearings, and finding the intersections and displaying them. Very promising. Very few controls, but they all have multiple functions. Practice. I've tried 2 or 3 times to use this on a hunt, and I just set it aside because I hadn't practiced enough to get the hang of what I'm doing. The other advantage of this is that you can input your magnetic reading directly, and then it automatically displays the true bearing here. So it eliminates all the hassle, but it would take a lot of practice. And if you can afford it, I think they want $3 to download it. So in the future, Gregory and I have been walking around the neighborhood. We've been doing triangulating on houses in our neighborhood just to get practice on using this. So I'm getting better at it, and next hunt I'm gonna be hunting with it. So I just put that out as a warning. But it eliminates a lot of the hassles of what I've been mentioning before in terms of things you have to do to be methodical. So promising, but plan on practicing. Plan on practicing with your radio. I don't know how many times I've gone out there and forgot how to put a new frequency into my memory. You know, I do it like what, once every year. Next slide. And this is kind of what it looks like after you take a few readings, and then you can get the intersection. When you go for a new reading, you line up in the direction that this is your compass now too. So you got to tie it onto your fancy stand there at the, so it wants to be level, I think. With your antenna, point the antenna, pick it up, and then you just press on this, and that builds a new vector there. And then you see how these vectors cross, and that's where your transmitter is. But it takes a lot of that stuff that I've been talking about in the beginning that was sounding pretty klutzy to keep track of. It automates it nicely. So try it out for $3. I think the free version is almost as good as the when you pay for it. Next slide. So summary. I think the most cost-effective approach, if you're a new hunter and want to try it, use your handheld. Even if it's not the best, start with it. You'll find some foxes easily, I think. Build up this tape measure Yagi that we've so nicely demonstrated here. Get a good compass. Figure out how you're going to keep track of it, either by paper or by sig tracks, and make sure that you have some way of attenuating. And as I mentioned, putting a dummy load on your radio if it's got isolation. Otherwise, it would work out fine. Next slide. So what's the process? Get your magnetic bearings, convert to true bearings, plot on the map, triangulate, repeat the ranges, pick the lowest, highest number. Pick the highest number. Go ahead. So just an example. For example, if you're down in our area and you're not getting good readings, you can always go to Woodcliff parking lot, which is the highest location in like 3 counties, I think, and you can get your bearings. So, for example, you got a bearing out this way, you can say, oh, it's one of these major parks, but then you go out the road, go off, not directly down the line, but go off you get an orthogonal reading, and pretty soon you can triangulate, and after a few readings, you can be pretty confident in that area. Next slide. Be strategic, be methodical, triangulate, get your bearings, have fun. Next slide. Thank you. Okay. So we're gonna put this online. I hope that you invite people that might be interested in fox hunting, because all the fox hunters are here.
Yeah,
So,
we'll definitely let people know.
yeah, go ahead and review it. And I put a lot of links in there so that folks can go and think that especially for building that tape measure, there's a step-by-step instruction that's featured in this month's magazine. Thank you.